And then we will talk about backpropagation. And we will talk about convolutional neural networks, and we will talk about autoencoders, and we will talk about some other stuff. So we will talk about different learning techniques in context of artificial neural networks, which is, at the moment, arguably the most exciting, the most powerful part of AI, which has given all of us excitement to be here today, are the artificial neural networks. So we will talk about many of them. So we also talk about things that, again, they have been a little bit ignored, like the self-organizing maps, like reinforcement learning. What you see then here and there, maybe since maybe a year or so, people have started to talk about reinforcement learning again. But you usually see it with the adjective deep before that, which is, I would say, nonsensical. There is no such a thing as deep reinforcement learning. It has never been. It will never be. Because reinforcement learnings are not a type of neural networks. They come from a different corner of AI. They do different things. You can connect it to the networks. Yes, you can. We have been doing that for 20 years, 25 years. And you can connect them to shallow networks or deep networks. So saying deep reinforcement learning is a misleading term. But we will talk about reinforcement learning agents. Arguably the only AI technology that can learn from scratch, from zero. It can start with no data. So just learning by doing, learning by making mistakes. One of the most exciting concepts in AI. So this is in many things that we are already using. When you go in an unknown environment, for example. So then we will go into uncertain versus vague, because this is actually what AI does. So if we have a situation where what is uncertain, we don't know what is what, there is no equation for it, or it is vague, we don't know, so is this or is it that? So we don't know the boundaries. Then AI can do a lot. So here we will talk about probability. We will talk about fuzzy logic. Whereas probability has been around for almost 300 years, fuzzy logic is slightly 70 years old, and it's still struggling. So this guy is still not being accepted in the family. So because it's a different corner of AI. So, but we don't have any preference. We will cover everything that has a little bit of hope of giving us artificial intelligence. So we will do that. And this class of techniques are really interesting because they will work with linguistically formulated knowledge. And it seems that one of the problems we have right now with deep network is that they are not interpretable. So giving 500,000 numbers to somebody and say, this is the decision, and I said, this image represents cancer, doesn't help that much. But maybe we can find some sort of smart techniques that can take a neural network, convert it to a bunch of rules that a physician can understand. So we will not give up. Many people are fast to say that we have to abandon logic. Nonsense. Absolute nonsense. There will be no AI without logic, without Cantorian logic, Boolean logic, fuzzy logic, any other type of logic. We need logic because humans use logic. So we need that in artificial way as well. So we will talk about those methods as well. And so, of course, here, decision trees and random forests are also among techniques that we should not abandon. In many cases, anybody who is using a deep network with 120 layers, I can easily challenge you, okay, give me the same features, and with random forest, I will give you the same results. It's an outrageous thing to say, because random forest is a collection of simple classifiers, decision trees, that we had in the second year. Just a tree, just a tree. Well, a tree is when you break it down and then you conquer it. Divide and conquer. It still works. Deep learning has not canceled out